Example 3. Scientists are attempting to reverse the effect of salt damage on land adjacent to the Hudson River. Data was collected and examined from a property near the river over several years. This allowed the scientists to construct the following table, which compares the proportions of very good, usable, and very poor land between 1 year and the next. Draw a transition diagram for this situation. So now we have 3 states, so we're going to have 3 circles. So our 3 states are very good, and that goes in a circle. We have usable, and that goes in a circle, and then we have very poor, and that goes in a circle. So this year, okay, so if I'm very good this year, next year the probability of being very good is 0.91. So that is an arrow that goes to itself. This year, if I'm usable, the probability that it becomes very good next year, so usable to very good, would be 0.3. And then very poor to very good next year, so from here to here, would be 0.02. If I'm very good this year, the probability that I go to usable next year is 0.06. The probability that I'm usable and stay usable is 0.65. The probability that I'm very poor this year and I become usable next year is 0.28. The probability that I'm very poor this year, the probability that I'm very good this year and become very poor next year is 0.03. The probability that I'm usable this year and become very poor next year is 0.05, and the probability that I am very poor and stay very poor is 0.07. Sorry, just 0.7. So if you look, all of the very poors add up to 1, so I can double check myself. So all of the arrows coming out of very poor should add up to 1. So I have a 0.7, a 0.28, and a 0.02. If I add those up, they do indeed give me 1, so I did it correctly. And we can double check for the other ones. 0.65, 0.05, 0.3, that adds up to 1, 0.91, 0.06, 0.03, that also adds up to 1, so I have put everything in the right spots. Write down the transition matrix T. So the transition matrix is pretty much done. We just take this thing that they've given us, this table, and turn that into a matrix. So I'm going to put that up here. So it's just copying down the numbers. In the matrix, state the meaning of each value. So the value of 0.91 means that 91% of the land is usable this year. Sorry, wrong word. 91% of the land is very good this year and will be very good next year. Or I should say the probability that the land is very good this year and will be very good next year is 91%. 0.03, so if we look, that means that it's right here. So it means that 3% probability that the land is very good this year. And very poor next year. And then the last one is 0.28. So 0.28 is that it's very poor this year and becomes usable next year. So that's 28% is very poor this year and becomes usable next year. Find the matrix t-squared and explain the meaning of these values. Okay, so in order to do this, we're going to have to put this matrix into our calculator. Second matrix, I'm going to move over to edit. I need a 3 by 3. Type all these in. Okay, so I have those in and it wants me to find t-squared. So I'm just going to go back to my home screen and then tell it to do matrix A squared. And then it wants certain rows and columns. So I want row 1, column 2. So row 1, column 2, if I look, I want to go back up here, help me out, use this table a little bit since I have all my labels. So row 1, column 2 means that after 2 years, 46.9% of the land that is usable in that year will be very good in the following year. And then down here, 0.5 means 50.5, if we round to 3 sig figs, 50.5% of the land that is very poor in year 2 will remain very poor in year 3. So that's what those mean. You can write those down. I'm not going to write those down. The initial land quality matrix is 0, 1/10, 9/10. Explain what this means. So 0 is the proportion of the land that is very good. So none of the land is very good in the beginning. 10% is usable in the beginning, and 90% is very poor in the beginning. Now to find the land quality after 1, 2, and 4 years. So after, you know what? We have this 2 matrix in our calculator already, so I'm going to do these a little bit out of order. But after 2 years, I already have that t in my calculator. That was the last thing we did was a squared. So what I'm going to do is I'm going to make my matrix B, just to save myself some typing. My matrix B is going to be my 3 rows and 1 column. And those numbers are 0, 1/10, 9/10. So then I have matrix A squared as my answer. So I'm going to do that times matrix B. So in 2 years, it's 0.151, 0.387, 0.462. Okay, so that is 2 years. They also wanted 1 year. So for 1 year, we're just going to do A times B. So after 1 year, it's 0.048, 0.317, 0.635. And then if I need after 4 years, I can do my second matrix A, raise it to the power of 4, and then multiply that by my matrix B. So after 4 years, kind of running out of space here. Let's see if I can make this bigger and slide it in. So after 4 years, I have 0.363, 0.366, 0.270, all rounded to 3 sig figs. Okay. So lots of work in this problem. It took a while, but I don't think any of it was particularly difficult. Make sure when you do this that you do actually write down the stuff that I did not write down there and just talked about. So the meaning of those values in row 2, column 1. So DI, row 1, column 2 was the proportion of land so row 1, column 2, that was usable. That will be usable in year 2 and very good in year 3. And then row 3, column 3 was the proportion of land that is very poor in year 2 and year 3.